Hi, my name is Danilo, and in this video, I would like to tell you about a software project that I've been working on called the Shell Gator. So, the Shell Gator actually is just my tiny attempt to solve a relatively minor software engineering problem that I've been experiencing over the years. But because it's such a small tool, I actually decided to try a few new technologies while trying to solve this problem. And so I've been learning and trying to use Rust language as well as the tree-sitter syntax parser library in this project. And so I guess this video is 50% about Shellgator and 50% just me reflecting on this first experiences of me trying Rust language as well as the tree-sitter library. So let's get started. So, as the name of the project might suggest, Shellgator has something to do with shell scripts. And in particular, it's trying to help making CLI out of shell scripts easier. And of course, the way to do that is to solve a few problems, but all of them are sort of revolving around argument parsing. And so, one of the primary goals of Shellgator is to make argument parsing extremely easy and convenient. In particular, I noticed that in other programming languages, some libraries use introspection in order to automatically prepare a definition of the CLI so that you don't have to actually explicitly define which are the possible parameters, which are the possible subcommands, and so on. Introspection uses the language's built-in ability to understand its own type system in order to generate CLI from the definition of the program itself. An example of this approach is something like CLIs in Python. Honestly, I don't know if there are other examples like that in other languages. This is just the library that definitely has inspired me to solve a similar problem for the Bash and other shell script languages. So I know that there are already existing argument parsing tools and solutions for Bash and other shell languages, but I feel like none of them have done exactly what I need them to do, and they're just too hard to use. And I would end up essentially in the projects in the past that I worked on, I would just end up having like a gazillion of different shell scripts, each of them having their own individual purpose, instead of having one unified CLI where I can sort of reuse code and group commands and subcommands and have arguments and have help functions or having help strings and so on. So this is sort of the problem statement. Can we make turning shell scripts into full-fledged CLI easier and not having to have this additional code and additional effort and time just to make a shell script into a CLI? So let's jump into a demo of Shellgator. Let's see what it can do. So here I have a shell script with three functions: function hello, function add, and function nope. And I would like to convert this shell script into a CLI where I can execute any of these three commands, and I can also get help to understand which commands are available in this shell script. If this script was actually like hundreds or maybe even thousands of lines long, it would be kind of hard to quickly see which commands are available for execution. And that's also why I would like to have a help output, and Shellgator will be able to do that. So let's see how it works here. So let's do test sh and just run this without any parameters. So we get back a help output which shows us that we have to first pass a command name and then some arguments, and then we have a list of commands here. First command hello, which has a parameter named name, and we have a definition or help information about this command. It prints a greeting. And then we have a second command add, which takes one required positional argument and one optional positional argument b. And we see here a help string tells us that this command adds two numbers. And finally, we have a nope command that does not do anything at all. So you might think that this is kind of a standard help output, but I want you to appreciate the fact that we got this help output without actually defining any logic at all with regards to how to output help. All we do here, we just define a few functions and use regular shell script commands like defining variables and comments in order to document our code. And Gator was able actually to use that information in order to compile and create a CLI dynamically at runtime. And so let's try doing a few more things here. So we have a hello command. So let's do test sh hello -- help. So we can see here detailed information about the hello command in particular. We see that it prints a greeting and it has a name parameter, which is supposed to be my name. So let's try running it. So we can do test sh hello Danilo, and we will see that now we actually executed the command. Instead of showing the help about the command, we executed the function hello, and it did what it's supposed to do. Let's now try the add. So we'll do test sh add -- help. First, understand what this command is doing. So we see here that the add command has two parameters, A and B, and A is required and B is optional. And if we look at the documentation, you see that this command adds two numbers and also uses a temporary variable. This will be important later. And the A parameter is a left operand, B is a right operand, and B has a default of 0, which is why it's optional. And okay, let's now try running this. So add 42 and 99, and we get out our output as expected 141. So this sort of shows us how we can now pass multiple parameters, and Gator takes care of routing everything into the correct function in the shell script. And finally, let's see what other commands we have. So we have nope command, which does nothing. And so if we do nope, we have nothing. So that's a quick demo. I was able to run all of these commands in a shell script, which doesn't have any explicit logic around having a CLI. It just defines some functions and calls Gator to take care of generating this CLI dynamically. So this might look like magic, and to be honest, it still feels like magic to me that I can just do this and get CLI for free. And so let's look at what's happening under the hood next. All right, so here's the main function of Gator. As I mentioned previously, it's written in Rust, and this is my sort of first attempt to make anything serious in Rust, and I'm still learning this language. So if you see some things which are not idiomatic or otherwise buggy or suboptimal, that's because I'm still sort of new to this language. So there's a lot of things happening here. I think the core of what we would like to look at is this here, where we construct this program struct out of the path to a script and out of the contents of that script. So if we go to this program here, we'll see that in this new function, which is sort of like a constructor, we instantiate a tree sitter for the Bash language. So as I mentioned also previously, tree sitter is sort of the key component of this, of how Gator works. Basically, Gator, all it does is it loads the text of the Bash script and then parses the abstract syntax tree, and then tries to find important relevant things in the parsed script in order to identify the functions and the parameters and the comments. So as you can see here in particular, we have three types of queries that we run against the AST. The tree sitter queries are the sort of like additional API that it has for essentially executing these very lightweight queries against the syntax tree. And so we have here the functions query that basically these are essentially S expressions, which are sort of like pattern matching against the syntax tree. And the name of the nodes here are specific to the Bash language in particular. So here we're matching against a function definition, and I capture the name of the function as well as everything that's in its body. And that's because within the body, then I would like to search for a few more things. I would like to find any comments that were found, that were declared or defined in the definition of the body or in the definition of the function. and also capture those. And also I have here a query, which is a little bit more complicated, and it took me a few attempts to get right, but I'm basically looking for any argument definitions or local variable definitions within the body of the function, uh, which in this particular syntax tree, it's considered to be a compound statement, which it has a variable assignment. And so I find the name of the variable, as well as the expression which is being assigned to the variable. And that's how I'm able to extract both what kind of variable this is. Is this a variable that's supposed to be capturing the parameters or the arguments to the function, as well as I'm able to get the default value if there's a default value assigned to this variable. And obviously, all of these things are extremely useful for preparing the help output for the function. And also here, I'm capturing more comments if necessary. So this is actually the core of how Shell Gator works, I suppose. It does that by essentially using TreeSitter to find functions, comments, and variable assignments, and then sort of parses those three types of language constructs in order to be able to essentially generate a help output at runtime. And besides generating help output, I guess what I forgot to mention is that there's also lightweight validation of parameters. So if I go back to the terminal at the bottom, if I do test sh add and then not provide any additional arguments, I will see that actually I'm getting an error here saying that I'm missing a function argument, expected 1, found 0. So the parsing of the script isn't just for generation of the help output, but also for validating the parameters to a certain extent. So let's go back to the main function. And so here in the main function, yeah, I'm just creating this program struct and then iterating over all the functions that were discovered within the script by the query. And then just constructing these function definition structs here with the function name, comments, its arguments, as well as where it was defined in the script. As you can see here at the bottom, help output also contains allocation of the function definition within the script, so I can actually go directly to the right place in case this is a big script. And then so here I guess I have execution of the command. So this one is actually a little bit interesting. So if we go back to the test sh script, we will see that we are not passing any arguments to the Shell Gator. We are just invoking it. So how does Shell Gator know what were the command line arguments passed to test sh? So for example, here, how does Shell Gator know that I gave add as the command line argument to test sh? So the way it works is using a little bit of Linux magic. We find get parent arg. So here we take the process ID of the parent, and then using this Linux functionality in order to get the command line arguments of the parent process. And that's how we find the correct command line arguments for the bash script. And of course, then we can continue processing the script itself, and then we can figure out what do we need to do now. Do we need to output help, or do we need to execute a command? And so, as was also sort of, I guess, obvious in the test sh script, when we wrap the Shell Gator command with the $parentheses, what happens is that whatever Shell Gator outputs and in the standard output gets executed by bash within the script. So if Shell Gator prints to standard output a add with some parameters, then in that case, the bash is going to, or ZSH or other shell script runtime is going to execute that function. And that's how Shell Gator is able to execute functions which were defined in this shell script by using essentially standard output. And the shell script promises to execute whatever Shell Gator prints to the standard output. So of course, now after Shell Gator is done parsing all of the arguments and figuring out and parsing the script, it now is able to execute command, and essentially all it does is just prints the command to the standard output. That's essentially all it has to do. So ShellGator actually has one more feature which I forgot to demo, and that's it also has a built-in REPL or interactive execution environment. And let's see how it works. So recall that previously I showed you an example where the shell script would start running and then at some point launch ShellGator as the sub-process. Now, there's a second way to use ShellGator where you launch the ShellGator first and then tell the ShellGator which script you would like to execute, potentially multiple times. And here's how it works. So I do ShellGator and then pass in the path to the test script, the same one I was using before. And now it launches this different environment. This I have here these two angular brackets. And I have now essentially access to all of the commands within the test sh. So I can run help and then get back the same help output as I was seeing before. And I can also now execute add, for example, like it worked before, and do also other things like go up in order to find a command that I previously executed, and do multiple invocations of different command, and then use arrow to go up again. And actually, this history isn't just part of the runtime. It actually gets saved to disk or to the file system as the test.sh.history. And so if I relaunch the ShellGator again, I can now do arrow up to get the previous command or any of the previous commands that I executed before this. So the idea here is that if you have a script which you frequently execute or maybe infrequently execute, but you have sort of these typical commands you run with the script, but instead of having to remember them yourself, maybe you can just have this local history file that's very specific to just this one script. And this way, a week later or a month later or a few days later, when you want to execute the script again, you don't have to try to remember, which are the typical parameters I pass to these functions. You can just look in the history to see what the typical output is. So that's sort of like an attempt to have this interactive REPL experience that you might have in other languages, but here it's now in Bash, or this semi-Bash hybrid of Bash and this ShellGator additions. So now a few words about what I think about using Rust as a language for making CLI tools. Now, I'm coming into this experience with my primary language for quite a few years now, being Python. And even though I use Python to develop a lot of software, I found it to be not a very good language for developing terminal tools and system tools that are supposed to be sort of shipped around in different environments for these utilitarian purposes. And the reason that Python, in my experience, didn't work out for making CLI tools like ShellGator is, well, two reasons. The first one is that Python comes with a giant amount of runtime dependencies. You cannot just copy paste the Python script and expect it to work in some random Docker container or some random server. You need to ship Python runtime, you need to ship dependencies. And even if bandwidth is not a problem, this is still a lot of things to ship. It's not just a single file as it is with Rust. And the other difference is that Python does have a bit of a disadvantage in terms of the startup time. And it's not just sort of like a hypothetical problem. The thing with CLI tools is that startup time is extremely important. If you want to use a CLI tool every day, all the time, you really need to make sure that it's able to start and execute fast. And unfortunately, Python doesn't quite allow that. Part of the reason is that in Python, when you load your program, you basically try to build this whole tree of dependencies. You import a module, that module imports another module, and so on. You have your whole tree. And in Python dependency management, every module is its own file. So you end up doing a lot of I/O just to load the program. While in Rust, is being a single binary, you essentially don't have this problem. So I think these problem actually sort of also are true about JavaScript and other interpreted languages. They not quite have the right trade-offs for building CLI tools. I think Rust here for sure had a very good experience for me because of the speed of startup time as well as being very convenient to ship into random environments. And then in terms of other features of the language, um, I did find some of the features kind of a bit unusual, and so I did have to learn some new concepts that I didn't see in other languages. I don't think it's a big problem in terms of once you understand these concepts, they become sort of just the things that you do all the time, just the way that it also is true about other languages. And I did find it actually quite convenient to sort of be able to leverage the type system for being able to catch bugs and issues with the software early, because it's extremely convenient to get warnings and errors right in your editor, as opposed to when you execute something 2 minutes later and now you don't remember what you were changing in the source code, what exactly caused this issue. So having a shorter iteration cycle is very important for development. And I think the compiler errors being so helpful definitely shortened my iteration cycle while I was developing Gator, even though I'm still new to the language. So these are sort of my thoughts so far. Overall, quite positive experience, I will say. And I'm thinking already about my next Rust project. I should obviously try something more complicated than a simple CLI tool just to see just how far this language can scale. Well, that's about it for Gator. I think I went into a lot of detail and talked about my development experience as well as how this thing works. And I think the one thing I'd like to come back to is sort of the problem statement. And I think I have identified a problem that I had in my own software engineering experience. But I wonder if this is something that other people have experienced as an issue and something that they would be interested in having a tool to solve this problem with. And so, if you had similar experiences or other relevant experiences with developing bash scripts or ZSH scripts or whatever shell scripts you're writing, if you have some relevant thoughts on this, let me know either here on YouTube in the comments section or on GitHub in the issues or anywhere else where you can find me. I would like to understand whether this is something that actually might be useful for other people, or is it just something that I came up with in my head and nobody else cares. Thanks a lot for listening and watching this video, and I hope to see you again. Bye.